Now we're going to be talking about doing different operations using functions. Here are different operations I can perform on functions. I can add them, subtract them, multiply them, or divide them. It's important to remember with division that the bottom of a fraction is never allowed to equal 0. So we're going to be taking a look at what it means when this function is equal to 0 and what is not allowed to be there. Now the domain is all the possible x values that I can plug into my function. So when we're talking about doing operations on functions, we're now going to be looking at the x values that work in both of the domains of the functions. Now when we're talking about the quotient here, any x values that make the denominator equal to 0 are not going to be allowed to be part of my domain. So now we're going to be adding, subtracting two functions. So when you're adding and subtracting, it's pretty much just combining like terms. The only thing we have to keep in mind is that these parentheses are going to be important to me. So for addition, I'm going to go ahead and f of x plus g of x, and now I put my parentheses here for now, but for addition, I'm just going to go ahead and drop the parentheses and combine like terms. So this is going to give me 10x. Combining like terms here, that's going to give me minus 1. So I'm going to have f plus g of x is equal to 10x minus 1. Now it is very important that you make sure you write the function name so that I know what operations were performed. That's the name of that function. Now when I'm talking about domain, if I were to graph this, this would just be a line. It would be a slope of 10, y-intercept of -1. So the domain here is going to be all real numbers. So the parentheses don't really matter that much when you're adding, but when subtracting, they're very important. So down here, when I subtract the two functions, now I have to make sure that I have my parentheses here because I need to distribute the negative to the second function. So I'm going to have 4x plus 7 minus 6x plus 8. So now when I combine like terms, I get negative 2x plus 15, and that's what f minus g of x is equal to. So again, make sure you put the name and make sure you put your parentheses so you don't forget to distribute. Now I want to think about if I would have done g of x plus f of x, would I have gotten the same thing? Well, addition here is commutative, which means it doesn't matter the order I do it in, I'm going to get the same thing. 7 plus 8 is the same as 8 plus 7. But subtraction is a little bit different. So let's just go ahead and do it the other way around and see what we get. So doing g minus f of x, remember to put your parentheses so I don't forget to distribute. Now combining like terms, I get 2x minus 15. So g minus f of x is equal to 2x minus 15. So you can see comparing these two functions here, they are not the same. F minus g of x is equal to negative 2x plus 15, which has a positive y-intercept and a negative slope, and g minus f of x has a negative y-intercept and a positive slope. So they're two different lines. If I graph them, they're going to be two different lines. Now the domain for both of these functions, again, since they're both linear, is just going to be all real numbers. Now we're going to be looking at multiplying and dividing functions. So first, let's do some multiplication. So f times g of x is the same as just saying f of x times g of x. Now our parentheses are going to be important here also. So I'm going to have x squared minus 9 times x plus 3. Now this is just double distributing. So I'm going to get x squared times x cubed, x squared times 3, so positive 3x squared, negative 9x, negative 27. So f times g of x is going to be equal to this function here. Now I have no like terms to combine, so that's it. Now the domain of this function, well, this is a cubic function, right? I'm not going to have any restrictions here, so the domain again is going to be all real numbers. So now let's do some division. So let's do f divided by g of x. So that's the same as saying f of x divided by g of x. So x squared minus 9 divided by x plus 3. Now we could do long division here, or the top looks factorable, so that's difference of two perfect squares. Now you can see that stuff lines up, right? So this guy here and this guy here are the same thing, so they will divide out and give me 1. So I'm going to be left with x minus 3. So f divided by g of x is equal to x minus 3. Now I want us to think about, would we gotten the same thing if I would have done g of x divided by f of x? Well, we would have flipped it over, right? And I would have got 1 divided by x minus 3. So there would not have been the same. Now if I would have done g of x times f of x, well, that's just a different way of multiplying. 7 times 8 is the same as 8 times 7. So that would have given me the exact same thing. Now talking about the domain of this second guy, things get a little bit more complicated. So with division, there's a few more things that we have to talk about. So domain restrictions really come into play whenever I'm given a quotient and the denominator is not allowed to be 0, and also whenever I have any type of even-rooted function. So we're mostly going to be talking about square roots, but remember this also applies for 4th roots, 6th roots, and any even-rooted function. Now when we're talking about even-rooted functions, what's underneath the radical is not allowed to be negative, because then we have imaginary or impossible values. So we're going to be restricting the values on x that make whatever's under the radical negative. Now that's going to look like an inequality. Now when I'm talking about quotients, I just am not allowed to have the denominator equal to 0. So we're going to be setting the denominator equal to 0 and looking at those x values that make it equal to 0. Now it's also important, this is super, super important, to check for restrictions before you start dividing and canceling out terms. So for f divided by g of x, which is the problem we just looked at, when we factored, the x plus 3 went away. But remember, you must look at restrictions before you divide things out. So before we divide out, what will make the bottom equal to 0 here? Well, let's set it equal to 0. And it looks like x equal to negative 3 will make the denominator 0. So there's a few ways I can state my domain. I could say my domain is all real numbers except x equal to negative 3. Or I can say it's all real x not equal to negative 3. So two different ways to write the domain with the restriction. So either you use the word except and then you put equal to, or you just say x is not allowed to be that number. So even though if I went and graphed this quotient function here, I would get what looks like a line, I still have restrictions because my original function before I divided out had a value that would make the denominator equal to 0. Alright, so let's look at this problem. Well, what are the restrictions on the domain here? Well, remember, first of all, the denominator is not allowed to be 0, and we have a radical. So remember, a radical, we can't have anything less than 0. I can't have a negative number. So I'm really looking at x plus 3. Now, it's not allowed to be equal to 0, and it has to be bigger than 0. So I'm going to put x plus 3 has to be greater than 0. So let's solve. X is going to have to be bigger than negative 3. So my domain here are all x values, all real x that are bigger than negative 3. And that's going to be my domain. So my restrictions are x values smaller than or equal to negative 3. So at the top here, we're going to be adding and subtracting these functions, and at the bottom, we're going to be multiplying and dividing. Remember to state your domain and any restrictions that the domain might have.